is for them. A little more practice. Share this here. So if you look at Canvas, you'll see that for this week, we're looking at week 10. You don't have a lot due this week. We have a lab Python name border program, and we'll actually work on that in class together next time. So we'll try to get that one done as a group. So that means at home, you should be practicing, doing more reading, you know, looking at that Python book, making sure that everything is clear, because looping structures can really be difficult for people to comprehend. So use that time to make sure that it's clear to you. Lots of practice exercises in our book that you can try with Python. So all of those kinds of things to just give yourself extra practice. So it's not a real assignment heavy week. Everybody kind of needs a recovery week, I think. So it's more for reading and stuff like that. So I'd been promising you that we would try a different editor besides Idle, because Idle isn't necessarily the most friendly product. So let's try one today. And then those people that are late and not here, when they look over and see your pretty screen, you can be like, oh, I don't know how you get it. No, you can help them. So what we're looking for is a product called PyCharm, P-Y-Charm. And so keep searching until you find this icon that's a little more colorful than our Idle icon. And you'll see it's from JetBrains. So JetBrains is a company that makes a lot of different IDEs, development tools. And they have an agreement with OTC for all the OTC students to get their software for free. So it's a really good package. If it's something that you're interested in, you can go to their website and register as a student and download all of the different products. PyCharm itself does cost, so you can use that OTC license to get it for free. There are lots of other editors out there that don't cost as much. One is Atom. Now, mine already looks different than yours, so I need somebody else to share. Let's share. Let me stop mine. Find somebody here to pick on. Look at my list. Who have I not picked on for sharing of things? Adam, would you share? You're sitting over there hiding in the corner. I'm going to look at your screen if you would share with us, and we'll kind of step through the process if you haven't already done anything. Will it let you? Oh, I bet it's on mine. Nope, not seeing it yet. Just click on share and then click the share screen. There it goes. All right. So if you're trying to open PyCharm for the first time, you might be seeing something like this, not like mine, because I already opened it. So we want to choose license server, because OTC does have the license server set up here on campus. Now, when you install it at home, you'll probably choose a different option. They'll give you information like an activation code to use. Yes, sir? That one's different. They do not import settings if it's on that one. And then, hopefully, it'll come to this one. Kind of slow the first time. And then, yeah, scroll down and accept. Don't send usage statistics. Are we there now? Now, license server, and then you should be able to activate.
So this is how we can do our Python assignment.
Yeah, you can use. That's okay. It's okay. Now, once you click activate, it's gonna check that license server and it should say, oh, everything's fine. Now, you do want to have Python itself downloaded to your computer and installed before you install PyCharm. Now, you have some choices for themes. You can use the dark or the light theme, whichever one you like. It's up to you. I went ahead and chose the light theme because I think that it kind of shows up better on the screen when I'm doing the Zoom sessions. But you guys let me know if you'd rather have the dark theme. The other thing is it seems like a lot of students like the dark theme, and if I use the light, then it's more obvious which screen is mine when you guys have 17 things open there. So pick whichever one you like, it doesn't matter to me, and then click next. Now on the featured plugin screens, we're not going to use any of those. So you can take a look at them and see what kind of things are available. Might be interesting to you. But then you can just click Start Using PyCharm. Now, PyCharm will work with all sorts of different programming languages. So we're going to have to tell it that we're using Python. So you can choose either option, create new or open. But if you already have all your Python code in one folder, just click open. And let's go find that folder. If you don't already have it in its own folder, click create new, and you can create a folder like a library for all of your Python code. So PyCharm kind of likes you to have that library set up where this folder has all of your Python code, and then it'll make it real easy for you to find all of the different files in that folder. So however you want to set yours up, your H drive is going to be your documents folder on that list because it doesn't really show you the names well. So if you go to your H drive, you should see your stuff. And then just click on a folder and click OK. So it's not really wanting an individual Python file to open so much as a folder. So go back, click on your folder instead of that individual file. Yeah, your web, that one. And then click OK. Is it doing it? There it goes. Now, when you get this firewall exception, just cancel or close it. Shouldn't hurt anything. And then you should have that helpful PyCharm hint that you can close, or you can look at all the tips in the world if you want to. So now, over on this side, this pane is going to show you that folder that you selected when you said you wanted to open. And you can see that we see all of the files and stuff inside of there. He's in his web dev folder because he was doing what I said, which isn't exactly what he wanted to do. He's going to go find his 120 folder. I'm going to disconnect you. Thank you so much. Give him a hand. Yay! Yay! Because it wasn't looking the same for me at all, was it? That wasn't a very good hand. You guys weren't very good this morning. Let's give him a better hand. Yay! It's a little better. Okay, so we want to be on PyCharm here. So what I have now is over here on this side is my folder, my Python folder for my CIS120 class. So I just did file, open, and then I told it I wanted to open my 120 folder. So it's showing me all of my Python programs and all of my Raptor things and everything that I've saved in that file. Okay. Now let's make sure everybody is there with PyCharm, and then we'll tell PyCharm we're using Python. Okay, so we have this next step that we have to do now that we've got it all started to tell it that we're using Python to run. Is it working? Looks like it's working. Looks good.
I think I missed the step. I still say that.
Yep, that's where we are. So you're okay. Click OK. Yeah, you guys look good. We're going to set up our interpreter now. on your folder. You have a Python folder. Oh, you got your Okay, so we want to tell this thing that we're using Python. And again, I already told it so that I could show you and make sure that it would work. So I need somebody else to take control here. Let's see. Ted's done it before. Simona, will you're right here in front. Will you take control, please? Remote control us. You can do it. Let me stop though, or else you can't. Okay, so click on the green share and then just click on your desktop and we'll be able to see everything.
I'm trying to find the
Are you not on our Zoom session?
No, I never do.
Oh, well, let's get somebody then that's already on our Zoom session.
I
Let's
just
see.
got everything on.
Did you get on there? Okay, just click share. Giving everybody a chance to see what's going on. That works great. Okay, so we've got to tell PyCharm that we're using Python. So if we click on a Python program, a .py file, we should see it open. And up here, will it let you click this down arrow? Edit configurations, that's what we want to do. I swear it's like different for each person. Is everybody's else look the same? Mine does. Yours does? Let's click the plus button. And we want Python.
Okay, just this one.
And
We want to.
let's do this a little different. Let's cancel here and let's go up to the file menu and choose new. And let's choose new project. On the file menu.
Oh,
Sorry, choose new project.
okay.
And then we want it to be pure Python. And this is where I went ahead and chose my 120 folder. So you can choose the folder that you've already chosen. Sorry, go around in circles a little bit when we have
Would it be?
your 120 folder. Yeah, that A-class assignments is probably good.
That's my, yeah, that's my one.
And then click OK. Now, it says the environment is empty. Let's click create.
No, it says
Down
it's
here.
not empty.
That's all right.
Okay. Yeah, it won't let me
It
select.
won't let you. Let's just do it completely different. Yours lets you.
I did make a new folder, but that's what lets me out.
So that's the CIS120.
Yeah, do you want to do file, new folder, or new project? I'm sorry. Because when we do new project and we tell it that it's Python, that's what's going to help us install that Python environment really easily. Lots of other ways to do it. That's just the way that I did it earlier. So let's just create any sort of folder and click OK. so that it knows that that's the environment that we would like to install.
So mine is saying the interpreter field is empty and it doesn't have any interpreter.
Okay, so click the drop down and you should see Python 3.6. That's why let's do it. Have you done it this way that we're doing?
Look at mine real quick.
No, have you done it this way that we're doing file new project?
Yeah, that's what I'm
Okay. Well, let me see what's going on with it. If it won't let us do it, we won't do it.
Mine did it. Mine's ready to go now.
Is it ready to go now? Click on one of our Python programs and see if you can run it.
Oh, and there? Do I have to move it over?
No, you should just be able to double click on one over here. We can't see what you said in there.
Mine's totally different now.
Oh, yeah.
Let me go, like, external libraries. Maybe. No, that's the Python stuff you told us not to touch.
Can you share it with us?
I'm sharing right now. I thought
You're not sharing what you're looking at, I don't think. Because it will let you share just one screen. Yeah, and then share again. And then share everything.
So it has like,
Now we're seeing what you're seeing.
I don't know, that was really weird. When I created my new folder, it just like, okay, so file, open,
Sure.
open, H drive, open.
And just
Whew.
now, if you right click on a file, one of your Python files, so right in here in this area where it's looking at that file, right click. We should be able to run. And then it's running. So it's found everything. Now, I know that was kind of kludgy, so let's get everybody's working, make sure we're all here together. Because it kind of does some things where it sort of works and sometimes it doesn't. How's yours?
I think
Can you run it? Right click and run it. Yeah, okay. So get a Python program open, make sure you can run it. Someone's doing that. Rid of Python for you. Is that why it's happening? Well, shortcuts are there. Looks like it's there.
Did you check the
no. So how do you just
You got some magic thing there. Now, while you're looking at PyCharm, make sure to find some different Python files, open them, run them, try to get familiar with things while we're getting some things problem solved, so that you're using the time to get more comfortable with it. You're probably already comfortable with other devices you might have around, so let's use this.
My life is furniture. I see school. I don't even go out and see that. If you school and listen.
Oh, yeah.
Which is good. Go everywhere.
Yeah.
Yeah,
I'm gonna make more money this year.
It's just a C.
Yeah, that's the years for that.
I know. My birthday's like New Year's. So it's super fun. Even if I go home myself, it's kind of not fun. It's not very good. I'm like, what? It's good. Yeah. I could definitely use it. So just crazy. You know what I mean.
Oh, yeah,
It's
it's
an interesting.
Yeah.
Three minutes. An object. Did you
No, no.
we went over the entire book before we started.
Oh, really?
Oh, that's a good one.
We used it last semester and I listened to it. Just had some students who were going to take it set up. So it was kind of easier to see what she was doing.
We did that last week. We did the same too.
And now paste it.
Gee,
And legend.
shit, bro.
This is too today.
This is scrambled. This is me and my family. You just yeah. Well, I wasn't even done with it by the time I started.
Okay, everybody's got it figured out. Yay.
Oops. She was still sharing. That was very nice. That's okay. Give her a hand. Yay. Yay. Thank you for sharing. Okay, I think we've got it installed now. I'm sure you don't feel super confident about doing that at home. That's okay. It'll work. Try things. Whenever you're looking for your Python interpreter, I say the easiest way I found was just to create that new project. And there are lots and lots of different ways, like the right way and all those kinds of things, but we won't be doing too much PyCharm configuration. Now, the file that I just happen to have open is the same new car price calculator that Simone opened, and I think it's a great one because it's a big program, and I want to show you how we can use the debugger in PyCharm. So our code looks pretty much the same as it does in idle, right? A little different, a little bit different font, but there's still color coding, and other than that, everything's kind of the same. We sort of lost some screen space because we've got all of these files listed over here on the left. So of course we can minimize that if we want to, slide it out of our way, our folder view. But what I really want to try is doing some debugging. So we use that visualizer site to go through and step through our code step by step. And we've seen how helpful it can be to look at memory and know what's going on in our code. So we can actually do that using PyCharm and the debugger. So I'm going to come to a spot in my code where I want to set a breakpoint. And a breakpoint is a spot where I want the system to quit executing my code and give control to me to let me look and see what's going on. So I'm going to do that right about here, I think, where we ask for the base price of this car. So in my code, that's line 29. I'm going to come over here in this gray area beside the number 29, my line number, and just click. And that's going to set that breakpoint. It's just that easy. So now that my breakpoint is set, if I use the debugger to run this Python code, execution is going to halt when it gets to that line of code, kind of like when we're looking at that visualizer and we just kept clicking next. So I'm not going to use the run icon. I'm going to use this little bug, the debug icon. And as soon as I do that, my process starts running and I've got my prompt down here in my console. What is your name? Well, I'll put in my name. So I haven't got to the line of code yet where I set the breakpoint. What type of car? I think it would have Volkswagen. And now I'm at the line of code where I set the breakpoint. So that line of code has not been executed yet. We're sitting there ready to execute it. I've got some variables here shown down here in this variables window, showing me all the different variables I have declared and what their values are. We see kind of our thread processing, like what called what. That doesn't mean a lot to us right now. But up here at the top of this debugger window, we have a bunch of different icons for things that we can do in our debugger session. We want to step into our code. We want to step into that line of code that we're waiting to execute and see what happens when we run it. But we have more than one step into option with PyCharm. If you mouse over these icons, you'll see the description is coming up down here in the status bar at the bottom. But you'll see that this first sideways one says step into the next line executed. Well, that would be good. I can step from line to line in my code. But the next one over, that's a little bit lighter of a color blue, says step to the next line executed ignoring libraries. That's the one we really want to use, because that's going to only show us our code. Because we really don't want to, when we use the statement print, we don't really want to see all of the Python system code that's involved in creating that print statement. We only want to see our code. So if you want to see that Python system code, use this first step into. But since we only want to see our code, we're going to use this step into my code. Now, when I do that, what's happening here? It's asking me for the base price of my car. So I need to find my console screen so I can enter that information. There's my console. So you have some different tabs down here, your debugger tab and your console tab. Click on your console tab and you'll see that input prompt. So the base price of mine will be $40,000. Now when I press enter, control returns back to the debugger. And it says, okay, now I'm sitting here at this print statement, ready to execute this line of code. So I'm going to click that icon, step into my code again, and we'll see it process our print statement about which engine choice, which engine choice we want. And then we're waiting for input on that enter engine choice prompt. Now I could click back on that debugger tab and see if the value of my variables has changed, what's going on with them. I can click back on my console tab to type in my response. I'll choose an 8-cylinder. Now when I choose an 8-cylinder and press enter, my program is ready to receive that input, but nothing's happened because I need to step into that code to make the next thing happen. So I'll step into my if statement, and my if statement says, was it an S? No, so it's going to branch to my elif. Was it an E? Yes, so the engine cost variable is going to be updated. If I do next again, we'll see the prompt for our interior type. I'll choose something on my console screen. Oop, I got to run it first. Where am I? Can get a little confusing. There it is. Now enter my type. I'll do V, and I'll keep running. Now, whenever you're using console input with the debugger like this, it can definitely get a little confusing that you have to jump back and forth. But I wanted you to see that it is possible. So if you use some of our other looping programs, like the one we did last time where we just displayed the multiplication tables, that would be a lot better of a choice, because as you use the debugger, you would just see those lines of code execute and see what was happening, and you wouldn't be stopping all the time waiting for this console input. So even our tools can depend on what program we're using. All right, so that looks good. Now, I'm done debugging, so I have some different options. I could stop, I could continue until I finish the program, or I can use the debug icons here to stop or pause. There's all my breakpoints. I can see what else is going on and stop my program. So the debugger really gives us a lot of power that we can use for different things to see how things are working. Okay, so is PyCharm working for everybody? To turn off that breakpoint, I'm just going to click on that spot again and get rid of that circle. And I'll be back to just executing. So let's look at our posters. We've got more people here now. Make everybody get up and move around. First of all, is your partner here? If not, you might have to grab a new one, because I want everybody to grab their partner. And let's meet here in the middle of the room. And you're going to take your partner and do a promenade. Oh, yay, fun. It sounds like square dancing. But what I want you to do is walk around the room and kind of review what the different loop statements were that we looked at last time before we look at the answers. So let's find a partner. If your partner's gone, grab another one. Try to remember what color Post-it note you had so that you know how well you did. So just look around, remind yourselves what they were. Since we didn't have time.
I was right.
Yeah, that's what that's really. Yeah, because I was actually having to do that too.
Yeah, and then these are the two, and then you're right. The third one. If you do negative diversity.
Yeah. I looked at the like program library and modules or whatever.
So the name order program is just a chapter 6 program in challenge 5. Okay, that I think I can do. The other one, the special purpose lab. I took a look at it. I don't know how to do any of it.
Is that one that's actually due?
Yeah, that's one that's due Thursday.
I'm not seeing it. Let me see where I can find
it's
it.
in week 11.
Oh, so
And
it's
it
just
closes Thursday at 3:30. Okay.
so don't worry about it. Let me make it where you can't see it.
Okay.
Okay, you shouldn't be able to see it. I got it at least unpublished. I've got to look at some of those dates. Because, yeah, you shouldn't have anything
it's
else.
It's a Thursday at 3:30.
Okay, yeah, you shouldn't have anything else, so don't worry about that one. And let me see. Okay, April 9th. I checked them all. I missed that one. Sorry about that. Try and not scare everybody.
Everyone who saw that. Yes. Current challenge I think I can do.
Can you?
The sum of squares, I have no idea.
Well, that one program we did last week where we just looped.
I don't understand how to make the loop work, though. To get the sum of the square.
Let's see what we're going to do.
I even tried Stack Overflow.
Okay. Let's see which one it was.
No, it was
So I've got it right now. I've got it where I think it'll work, but I just can't make it print.
This is it. So we called it, or at least I did, a really long name. Chapter 5, for loop with user input. So you're going to prompt for the ending number instead of the starting number. And then your for loop is going to be set up using those variables. And then...
But I don't know how to make it so that it's the sum of all the square numbers within that range.
In your for loop, you would just add to a sum variable.
Okay.
The value of x. So up here you might say total equals 0, and then within your for loop you would say total equals total plus x, and that would give you a sum of all of those items as you loop through, and we'll do one of those today.
X would be for x in range
1 to my square.
Yes.
Okay.
Uh-huh. Perfect. You've got it.
Hey,
Hey.
you're gonna hate me,
Why?
but I can't make it to the testing thing today.
Oh, okay.
I got an important doctor's appointment scheduled for
Oh,
today.
good luck.
Yeah,
Those
well,
important
they're gonna
doctors.
start me on shots to hopefully get rid of the alpha gal.
Oh, great.
It's something new that they found or something
Good
like
luck.
that. I'm a guinea pig test dummy.
Guinea pig. Be careful. Be careful, because that one they used is made like out of hamster ovaries or something. It's just got reactions to it. It should be okay.
I hate being a guinea pig on a new shot. Though.
So when are you going to do that test?
I'm going today to get approved for it.
No, I mean the test I care about. Yeah, I'm kidding.
Oh.
The unit 2 exam. I don't know.
I can do it Thursday.
Thursday.
Yeah.
Let's see what we got there. Alrighty. Yeah, I hope. Well, you could be in the hospital by Thursday. You just go to those doctors. There's no telling what kind of terrible things they'll do to you. Good luck.
Thank you. I'll need it.
Are you going to? Is it Farrell Duncan people?
The people I'm going
Allergists?
to. I'm going to her name's Dr. Huebner. Yeah. It's over by the Meyer Center. It's a Springfield allergy and asthma.
So I think that is Farrell Duncan. You'll have to see, because I think they're ones that were pretty early on.
Yeah. Okay. Yeah. Also the right place to be too.
Yeah.
Something happens.
Better than
That's my thought process. Every time
better
I'm there,
than
I'm
the
like,
emergency
something
room.
happens. I'm the best place ever.
best place. Okay, grab one. Grab your partner, grab a question, stand by it for us, and let's grade these things. So we're gonna have to move around a little bit. I have a few people. Come on, people, let's participate. Come on, people, let's participate. I would love for to sit and read while you were talking. I will do that someday. I'll get a chance. Okay, so for number one, where's number one? Nobody's at it? Somebody get to it. All right, we need a good person at number one. So what we're gonna do is grade each one. So we're gonna look up here at the big screen and see what the answer is to this, what the output would be. And then our graders are gonna go through and find all of the pieces of paper that have it right. And the ones that have it right, we're gonna bring them up here on the board and we wanna stack them. So if the hot pink people got 7 right, we should see 7 hot pink Post-its here in a stack. So she's gonna get us started, bringing over all of the ones that they got right on this one. Now this very first one, what is our output?
She's gonna output each letter in the word Python.
Isn't there something else too? It's gonna print out that word current letter and then each letter in Python. So now our grader is gonna decide about that. You know, what about that current letter? How important is that in your grading attempt? You're gonna have to decide as the grader, because sometimes it's hard to grade people's programming stuff because you're like, that's pretty good, they did good. All right, what about number 2? We've got a list of fruits here. We haven't done lists yet, but I think you guys figured out what the output was gonna be on this one pretty quickly. What was it going to be?
It'll print current fruit, and it'll go through the fruit.
Banana, apple, mango. Okay, so grade number 2 for us there, guys. And again, you decide how hardcore you're going to be on grading requirements. Oh, she's got it started. Perfect. Okay, number 3. Do you guys see number 3 anywhere? All right, yeah, we got some people at it. All right, what's going to happen with this one? For x in range 0, 3, print we are on time %d %x. What are we going to get?
I think we'll say we're on time 0. We're on time 2.
Perfect. Everybody agree? Does that sound right?
Yeah.
That sounds right. Okay, bring all of our right ones up here as you get a chance. We'll keep them going here. What about this one? This is number 4. Does anybody see it anywhere? You guys got it? Great. Okay, so this one, says we're going to set x equal to 1, and you guys will see this a lot when you're looking at code snippets like this. While true, print to infinity and beyond. We're getting close on %d now, %x, and then we add 1 to x. So what's our output going to be? So how many times is it going to print it? Forever, infinity. It's an infinite loop. So again, our graders are going to have to decide how are you going to handle that, because it is an infinite loop. They might have just written that. They might have written the message over and over and over. So we're okay with that as long as they got the idea. Now this one threw a little bit of the old Python 2.7 syntax at you so that you could see the X range. Comes out, it's just exactly the same as the range statement, isn't it? But that way, in case you see some old code, which you will, it won't throw you. So what's our output going to be for this one? It's kind of big. So again, we're going to... Dang, is that your assignment that's due tonight?
I don't know.
Almost, isn't it? Because what's it doing? It's printing out a message, the number, X,
Oh, this is that same one that we.
then the number Y, then X times Y. So again, very close to your assignment where you're supposed to print out a number and that number squared, that number times itself. So super, super close. So what's this one going to output?
It's going to print out, each line is going to have the value X, value Y, and then the value of those two multiplied.
So it has 1 times 1 equals 1.
Mm-hmm.
1 times 2 equals 2.
And
1 times 3 equals 3.
And then it'll go through 2 times 1, 3 times 1, all the way.
Yeah, so they're going to have summarized on this one.
Yeah.
So whoever's grading number 5, be flexible with that. If they've got the right idea, that's what we're looking for. All right, this one again uses the X range, no different than the range. But it says for X in X range 3, if X equals 1, break. So what's this one going to output?
It's not going to happen anything.
Nothing, is it? There's no print statements even. So
Yeah. It would go through a 0 and it would go through a 1 stop.
it'll waste some processor time, but it won't output anything. Okay, what about this one? This one's kind of weird. Here we're saying while X is in this range of 0 to 3, print it. Otherwise, print final X equals that number. So we know we're going to get printed 0, 1, 2. What's the last one going to print out?
The last one.
2, X will be, or 1. 0, 1.
Should we try it?
X will be 2. Final X is 2.
Let's try it. I'm going to have to use the newer syntax. Let me see if I can get there. Else, print, final, X equals %D. Then we have our %, use our X variable. Oops, I was using that old syntax, wasn't I? And I don't have my parentheses on my print statement. Let me fix them both. And that was a hard one, and you guys handled that really well as far as, you know, is this a syntax error or is this a difference in syntax? That's something we always have to ask as programmers. Even when you go take certification tests, you could run into things like that. Is this answer right because you want me to consider the old version, or is this answer wrong because we're only looking at the new version? So yes, we had some experts here. Final X equals 2. That's all right. I'm just trying to learn. Okay, what about number 8? Has anybody got that one? Oh, we got some good stacks going here. For number 8, our string was hello world, and for X in the string, we did the print of X. So what's our output for this one going to be?
Hello world.
Yep,
Oh,
stacked in a column, right? Yeah, a columnar hello world. Okay, this one we might have to enter. This one we start with a variable named count, initialized to 0. While it's true, we're going to print it. Then we're going to add 1 to it. And if count is greater than or equal to 5, we're going to break. So what's this one going to output?
And 0 through 5? And then break?
0
Or
through
0
4.
through 4.
0 to 4.
Oh yeah, it's gonna print 0 through 4 because it would update to 5 and then stop before it's printed.
Good job. That's what it will do if we got number 9, 0 through 4.
I think that's what we think.
Great. All right, this one, we're doing a little bit different of a thing. We are running a loop up to 10, and inside our for loop, we're doing that modulus command to divide by 2 to see if we have a remainder. So we're looking to see if x is even. If it's even, it's going to continue, which means it's going to come back up to the for loop and reevaluate. But if it's not even, it's going to print it out. So what are we going to get?
So 1, 3, 5, 7, 9.
So we should get our odds on that one. Does that make sense? Number 10. Does anyone have it? Do you guys see it? See it? See it? See it? Can you get it? Oh, thank you. Thank you. We've got it. All right. What about the T? This one is a loop where we're decrementing, right? And we can do that with our for loop. So instead of having like a for loop that always increments, we can actually add a parameter to tell the for loop we want it to go down in value. So in this one, we start with our temperature at 115. While our temperature is greater than 112, we're going to print it out and then subtract 1 from it. So what's our output going to be?
It's going it's going to be printing 115 and then 114 and then 113, and then once it gets to 112, I don't think it's going to print that anymore.
Right.
Stop, and then it'll print the T is cool.
Perfect. Does everybody agree? Well, 15, 14, 13, the T is cool enough. Good. And this is our last one. We're going to set I to 4, and while I is less than 9, we want to print it, and then we're going to add 2 to it. So it starts out at 4. So what are we going to have output from this one?
Going to output 4, then 6, and then 8, and then it'll update 10 and stop.
Perfect. Everybody agree? Look good? Looks good. Thank you. Yay. Okay. So how are we doing? Oh, really good. We're still grading. We got some that we're checking. So far, so good. Really good.
So that one that checks for even numbers, it had, so you know how it has only one variable in the range?
Uh-huh.
So whatever, that defaults it to start at 0, right?
Uh-huh.
Would that not give a runtime error for trying to divide by 0?
No, because we're not dividing by 0. We're dividing into 0.
Well, it divides 0 by 2, right?
Right.
Can you do that?
Yeah, you just can't divide by 0. But apparently you can divide into 0 and just get 0. But that's a good point. Oh my goodness, look, some of them are getting so tall. Yay! How do they look now? Do you remember what color you had? How'd you guys do? Looked really good. They looked really good. I think you did great. Give yourselves a hand. Yay, awesome. And I like doing that because that way you guys get to see all these different looping statements that we couldn't create on our own if we tried. So, yay. Find your seat. We are all done. You guys have done great with it. You should feel smart. You guys are smart. Look at that. I love that one. You're very smart. Very smart. What's smart?
I've never taken a programming class this early again.
No, it's too early, isn't it? You guys have done so good. That's why I try to not complain about late. This morning I was just like, well, maybe more people will show up, and you did.
I showed up.
It's hard at 8 in the morning, apparently, for 20-something people.
I just got off work at 1 in the morning.
That's why. That would make it really hard. One of the assignments that was due tonight is the loops with Turtle on the Runestone thing. It's not doing a very good job at showing me your grades. So I am.
Three assignments that you
I got
graded
100% on it.
Oh, so it's showing me yours. Well, if it doesn't show up, or if I give you a 0, do a screenshot and submit again on Canvas. It should let you submit it again.
Even if it was like a past assignment.
Yes, even if it's a past assignment.
Academy and Runestone, I got
Yeah.
a 0-1.
Just go ahead and submit them on Canvas again, and then I'll see that you submitted it again. So it might take me a while, but eventually I'll get them. So let's take a look at this loops with Turtle, because this is going to be kind of a neat one.
Okay, so we actually have the full work. I don't know why my.
Where's this at? What website is it?
This is the Runestone Academy. So just search for Runestone and then see if you can find your account. And I can look and make sure you've got one.
Is that what we do?
Yeah. So go to the Runestone thing. See if I can get logged on.
I think our logins were sent to our email.
I can look and see, I think, what your account is.
There's an actual stone. I didn't know that.
I always just remember the old RuneScape one.
Oh, yeah.
That's the one that I always think of.
Interactive. Oh, it's one of you.
Yeah, Nick, you have an account, so you should be able to sign in. But if you,
I got it.
you did it, okay, good. All right. All right, so I'm going to try to find this chapter. And I know we could go to the assignments, but if we just scroll down, it's the same way. And I want to do this section 8, more about iteration.
What?
What's it doing to you?
No, it's not your email.
Can you get to it? Let me log in.
I just don't know what to do. No, that's it. You're gonna make it.
I'm sure he's confused with as much as he's had to run out. Okay, so we're looking at iteration revisited. Remember, iteration is an execution of a loop, or to iterate. So computers are often used to automate repetitive tasks. So think about a robot. He's just in a never-ending loop, right? He's just going to check this thing, move it from here to there, all of those kinds of things. So let's mark this as completed, and then click Next section. Now, here's where we really want to be looking at the Runestone stuff, because we can do some practicing. So here are some different for loops for us. They say, recall that the for loop processes each item in a list. Each item in turn is reassigned to the loop variable, and the body of the loop is executed. So the previous chapter also talks about looping, so you can sure go through that if it's something that'll help you. Whenever we're looking at the Runestone site, we can click Save and Run to run the code that they've got for us. And then we can see in this example, they use a for loop that's going to be controlled by a variable f. But after their in statement, instead of having a range statement or some sort of string like we've seen, they have a whole list of items enclosed within square brackets. And then our print statement within the for loop uses that f variable to get each person's name from that list. So that's kind of a handy one. So we could change it if we wanted. Let's say we want to say, please come to my party on Sunday. And then we could save and run. And let's see our code changes. So anything that you want to try, you can try on the Runestone site and just run it. Then remember, it has this link to the code lens, which is that visualization site. So if we click show in code lens, we can see the visualizer right there on our screen. And now I can click forward through this for loop to see what's happening with my f variable. First, it gets assigned the value of Joe, the first one in my list. So I click next, it prints out the message to Joe. Then it gets assigned Amy, the next one in my list. And we can just keep using that code lens to see how things are executing, to go step through our loop. Now, the next example shows a def statement. This def statement defines a function, which is a subprogram in Python. So we'll be looking at those soon, but we haven't quite got to it. It just basically is a piece of logical code that we can execute standalone. So in this example, we're going to use the print statement. And in the print statement, we're saying run the sum2 function and pass it an input value of 4. The sum2 function takes that input value of 4 and names it a bound, and then it uses it within its code to control the loop. When it's all done, it returns as output the sum of all of those numbers that it looped, and that's what we'll see print out. So we could save this one and run it and see our two output statements for the different sum2s. Then again, we could run it in the code lens. First, as we go forward, we'll see that it skips everything in that function, just reads it. And then when it gets to that print statement, it actually runs that sum2 function, which runs our for loop. So don't let that function bother you too much. Just know that that's code that's containing some other code. Now, whenever you look at the bottom, the last bit of text that they have, they say that the variable the sum is the accumulator in this example. And that's because it starts out initialized to 0 before we start our loop, and then we use all of the values produced by our loop to add to that sum variable. So let's mark that one as complete. And let's look at our next section. Now we've seen the while statement a little bit. Here it is in a flowchart. And in this example, we're going to use a while loop to control our loop, and instead of using a for loop. So we have the same sum2 function. We're using the same inputs to it, so we should get the same output. We're just using a while loop to control that instead of a for loop. So compare those differences. You should be able to code things that you need using either type of loop if you have the right amount of information available. They even provide you some nice convenient workspace there at the end, and there's some examples. Let's look at the check your understanding. So the true or false down at the bottom, you can rewrite any for loop as a while loop. True? So whenever you're in a study group and someone's looking at your code and they're saying, oh man, you need to change this for loop to a while loop, question that person. I've heard people say that. It's really not a matter of the loop. It's a matter of the loop being properly formed. All right, this next one, the following code contains an infinite loop. Which is the best explanation for why the loop does not terminate? What do you think? It's what?
Because it's increasing, so it should.
So which one is right, A or B? A? Because B is talking about the wrong variable, isn't it? So important. Because they both are starting positive and increasing forever. Really good. Okay, what about this one? What is printed by this code? We have n equal to 1, x equal to 2. While n is less than 5, we're going to print out this stuff. Well, actually, we're just going to run our while loop and print it out when we're all done. So think about it. One of those test questions where you might need a piece of paper. 5 and 7. Do you guys agree? 7 and 15. You thinking? You're going to start out with n equal to 1, and we're going to run our while loop while n is less than 5. Within our while loop, it looks like we add to n once. Oh, and then we add to n again. So we basically add 3 to n within our while loop. So how many times is that while loop going to execute? Twice. So that first time through, it would end up being 2, 3, 4. And then the second time through, it would be 5, 6, 7. So Ted's just being sneaky there and trying to figure out a way to come up with the right answer without going through the whole thing. Very good. Let's mark that one as complete. Okay, this is the turtles. And turtles, kind of an interesting thing that we can use within Python. And I'm going to try to show you some cool ones. Let's just run this program here real quick. And do you see what it did? That little turtle there was activated. So let's take a look at the code. We started out with these 2 statements to import things. Those are statements that tell Python that we want to use some Python code that's available in other files. So we want to go to those files and bring those files into our program. We wanted the random file and the turtle file. So then in our program, we define a function, a Python function. This function is called isInScreen. And it requires input of like a width and a height, and it's generating a random number. Now, that's all that function's doing, so I'm going to continue on. The function is just like an if statement. Once we're not indenting our code anymore, the function is over. So right here on line 11, we're basically to our main method, our type of code that we've been using. So we declare a variable t, and we say set t to be a turtle. Then we declare a variable wn, and we set wn to be a turtle screen. Well, that's what opens this window here for us, the turtle screen. Then we say our turtle, which we named T earlier, if you remember, we want to set its shape to the turtle shape. So that's why we see the little turtle shape there. And then we're going to use a while loop to say while our isInScreen function keeps returning true, we're going to flip a coin. And if our coin toss, using a random number, comes up with a 0, we're going to turn the turtle left. Otherwise, we're going to turn the turtle right. And then we're going to have him go forward a little bit. Let's copy this program and put it in PyCharm and see if we can run it ourselves. So in PyCharm, I'm going to go to my folder. And I'm going to say that I want to create a new Python file. So right-click on your folder and choose New Python File. I'm going to name this first turtle.py. And I'm going to paste that code. I have to find my settings to get my font a little bigger, so I'm not being able to scroll. Okay, so let's see if we can run this using our PyCharm. Didn't work very good, did it? I got my output here, 0, 1, 2. Whoops, that's my previous one. Are you seeing anything? Is it working for you? Good. Ah, I was in the wrong place. Yay. Okay, so my turtle this time did more than what it did when we were looking at it in the example because it's all kind of random. So I'm going to run it again. What I had to do was I had to right-click on my turtle file and choose Run First Turtle. Now, the reason is I have a lot of tabs open here in PyCharm. So when I just clicked this Run icon, it ran whatever program was listed up here in this drop-down list, which wasn't my first turtle program. So I wasn't running the program that I wanted to run. So always make sure PyCharm is looking at the program that you want, or you can just right-click on the code and run it. Now, the reason that turtle is kind of neat is because we can use it to illustrate some looping things. Now, in this one, we have some good examples of how to do a random number in Python. And I want you to have that code because it might be handy for you here soon. So right here, we say we're going to import the random library. We need that. And then we say we're going to set our coin toss to something in the random library called random range, and we want that random number to be in the range of 0 to less than 2. So we're going to get 0 or 1, right, in our random number. And then we're using that coin. Did we get a 0 or a 1 to know whether it was a heads or a tails that was flipped? So we're doing some important code in here that we're doing a random number check. So let me give you one to try here, if I can find one.
You have to put the .py on the file again.
You shouldn't have to with PyCharm. It should figure it out for you. So let's create a new one. And we're going to do some spirals. Actually, I don't like that one. Some of these get really complicated really fast. I just would like to find a nice one for us. So let's just create our own. Can we create something that makes our turtle move? I want to create a new Python file in my folder. And this one I'm going to call second turtle. I want to close out all these other tabs. I'm going to keep my first turtle tab and my second turtle tab open, but close all the others. And then when I right click, I should be able to split vertically and see my first turtle beside my second turtle. Can you do that? You see it? So you're going to right click on your tab and choose split vertically if you want to see both of those program files side by side. So let's create your own turtle. We want to import turtle. And then let's say t equal turtle dot turtle, just like they did. And then I'm going to say window wn equals turtle dot screen. Now I want to set my turtle shape. It says that in this code we use the turtle picture. Can we use some other picture? Let's go to Google and see. Python, I'm going to search Python turtle shape. Now I see a bunch of links here. You can just look. You don't have to go searching with me if you don't want to. But I'm going to look and kind of see what kind of different shapes we can use with our turtle. And that doesn't look very helpful. We'll try the next link. That takes us to our textbook that we've been using. Stack Overflow is usually a pretty good place. Now I see right away they say that we could make our shape be a circle. So we could look around and do some searching and see what all kinds of shapes and options do we have. Let's try a circle. So instead of turtle, I'll put circle. I'll just copy that other code since I've got it right here beside me. I'm going to copy this function and put it right here at the top of my code. And then I'll copy everything after setting the shape, that while loop. Now, if you notice, I have an error every time that random function is used. because I'm missing the import random statement. Now we should be able to take that code that we were given and just change it a little bit to have something different happen. So we're just going to try changing that shape from that turtle shape to the circle shape. So I'm going to right click here and run my second turtle. And yeah, now I see that circle creating this thing instead of the turtle. I think there are other things I could change. Could I set the color? Whenever I type T for my turtle name and a dot, PyCharm pops up this list, this IntelliSense list of all of the different things that I could do to that turtle object. So let's see, I would like to change its color. I'm thinking I don't like that black. So there I see that there is a color. So I'm going to try it, t.color. Then I need to pass it something, like what kind of color I want. So let's try green. That should be a color. I'm guessing because I'm not Googling it, but I could go Google it and find exactly a list of what all colors are available. Now I'm going to run my second turtle again, and I see that my circle and my line are green. This one ran a lot longer. It took a longer time to generate a random number that made it stop. Now, if we wanted to, we could add some code to our program so that we would know what the random number that was generated is. I'll put it in here in my isInScreen method. I'll print. Oh, we'd have to save it. We're not saving it in this one. So we can do it down here in our coin toss. After we generate our random number, let's print that coin. And then we'll see what our random number's value was. What's the matter? I can help. I can help. Let me help.
It's okay. Sketch it.
Oh, I don't know. I'm trying to type it all out.
Right click on it. Just right click on it.
Yeah. Well, I don't have it right now.
Now we could change this program real easily to be some sort of coin flip program if we wanted to tell somebody that they won or they lost or whatever we wanted to do with that. Now in my console output down here, since I added that print statement, I'm seeing those coin toss values. I'm getting my zeros and ones. When we're working with random numbers like that, the system itself is going to develop a seed number, and a seed number for a random number is really important. A seed number is what's used to generate random numbers to keep the numbers random. And if we have a seed number that doesn't change or is not usable, we're going to end up with the same random number over and over. So we always want to check our output to make sure we're getting good random numbers. A lot of times for our seed number, we'll want to use the current time or something that's really unique so that we know for sure we have a good, unique random number seed value. Okay, did you get it to run? Get it to run. We will fix it if there's problems. We want to look at our Runestone Academy. Still have it going. Now, in the Runestone Academy, there's a lot more information about the turtles, and I have some other activities for you to try. If I look at the chapters here, I'm going to go back to the main table of contents. It's chapter 8 that we're looking at. There are some more while loop items for you to take a look at. So be sure to go through that, because the Runestone Academy in the text is very simple and very short, and they explain things very well. So it's a really good way to look at things. Everybody seems to be struggling today. So let's close out of all of this stuff. PyCharm just made your brains hurt. So let's just make me talk at you and make your brains hurt even worse. We'll look at everything now. Let's go to your modules. And in week 10, let's pull up this PowerPoint, more about loops and decisions. We've done a lot of different looping things, and it's so hard to know what the best way to handle things like this is for students, because when we looked at the Raspberry Pis, if you got an opportunity to get your Pi up and working, and you got the light blinking, you should have had an opportunity to see visually that for loop working so that you get a good idea of what's going on with it. A lot of the sample code that we've created, again, tries to give you a visual of a while loop executing or a for loop executing, because these are really important. This is a time of semester where we can get distracted and have a lot of things going on. We really want to focus on these looping constructs because they're really important for us. And they're things that you'll get a lot of opportunity to practice with. So it's not like this is the only day. So you guys have already seen this. I think we've already combined if statements with loops. You know that you can nest things. You can nest loops inside loops. You could nest if statements inside loops, loops inside if statements. So we can get really in depth, and we can structure our program exactly as we need with whatever we need. Now, one reason, oops, this one, I'm jumping here. We might need to exit a loop early. Again, with our examples, you saw some examples of that where we have break statements. The break statement breaks all the way out of the loop. The continue statement makes us reevaluate the condition, right? So we can redo those things and break out of our loop early. Here's a loop that runs till there's no more money. Take a look at it. What kind of language is this? Is it a language that you're familiar with? It looks sort of like pseudocode. Is it pseudocode? Sort of like C#. So it's not exactly one that you've seen a lot. But what I hope is that as you look at it, you can kind of try to figure out what's going on in it, right? So even though it's not a programming language that you're familiar with, you should be able to look at that code and kind of read that code and get an idea of what's going on. So we see at the beginning, we have some numeric variables that we're declaring. We have a total that we're starting at 0. We're outputting this prompt and reading in the maximum amount that they want to spend. Now we're going into a for loop, which is different than our Python for loops, right? But we get the idea that we're going to run from 1 to less than 11. So even if you don't understand the exact code that's going on there, you can kind of figure out what's going on. Within that loop, we're going to ask them how much money they spent on something. We're going to add that amount to our cost. If the total cost gets greater than the maximum amount they wanted to spend, we're going to issue a message and exit our loop. We're not going to let them buy anymore. So it's kind of like running out of money on your credit card. Here's one, again, that's pseudocode-ish, and we're doing a guessing game. So in this example, we have some really nice pseudocode for how we would set things up if we want our user to guess a secret number. We saw just a few minutes ago how to generate a secret number with a random number in Python. So we should be able to generate a random number, then use this logic in this pseudocode to write a program to guess the random number. Set up a game. Here's an example where we're adding loops and decisions and we're validating data. Now, validating data is where we're making sure that a number is numeric. In Python, that's a little bit difficult to do, or it requires some skills that we haven't learned yet. So we'll take a look at those. But for right now, we won't validate that a number is a number, but we can validate that a number is within a certain range. We might need to validate things in both ways. Whenever we start with loops and decisions, we're working towards longer programs. That's why it can get confusing. So we want to make sure that we're keeping track of all of the different things we have going on and try to minimize each area's complication level. Keep it simple so that every area is as simple as possible. In this example, we're prompting a user for input. We basically did this program. You should have it in your files, except that we didn't add in how many positive and negative numbers were entered. We just printed out the number. So we can do that pretty easily. Here's a flowchart for that program. We start out in our flowchart declaring our variables, initializing to 0 are things that we need to use as counters. We prompt our user for a number and tell them to enter 0 when they're done. That's our terminator character, the 0. We want to stop. If the number is 0, we're going to go to the end. They're done. If not, is the number greater than 0, we're going to add to our positive count. If the number is not greater than 0, we'll add to our negative account. Then we'll ask the user for a number again, and we'll check to see if our number is 0. And do the whole thing all over again. Sometimes it helps to visualize it with the flowchart. Now in this presentation, there's a few random things that I'm just going to throw at you that are important. The length of function is an important thing. The length of function expects you to pass it some input. So in this example, we're going to use the length of function to figure out how long the word hello is. So after we've run this line of code, the myLength variable will have the value of 5 because there's 5 characters in that word hello. The next one, the length of goodbye, would assign the value of 9. What about ceremony here? Does that space count?
Yes.
Yes. So anything within our double quotes that's part of our string counts.
Actually, I believe the only thing that doesn't have that extra space is like, isn't the lowercase letters?
And it'll count. It'll count as a character. Mm-hmm.
Well, I know, but in the lowercase letters, if you do it in between those A to Z,
Uh-huh.
I believe the only one that doesn't have the space in it is the lowercase. So I just saw it.
Just looking at stuff. Now we've done this also. We did our print statement with the \n, the new line indicator, so that we could go on to a new line. We also did some output with the \t, the tab indicator, so that we could indicate a tab character. So in this example, this is a lot like the one we're going to work on next time as our lab. They're using the length of function to format some things. So let's see what's going on here. We declare some variables, set a count as 0, and then prompt for a name. We're going to keep the name in the name variable. Then we prompt for a symbol. Do you want a star or a hashtag? And then we save that in our symbol variable. Do you want a space between each symbol? Yes or no? And then we save that choice. Now, we're going to set up a variable called number, and it's going to be set to the length of the name that was entered. So if their name is 15 characters, number is going to be 15 characters. We're going to go into a while loop then and print out the symbol that they wanted, whether it was the star or the hashtag. And then we're going to output the symbols to print around somebody's name. You guys will probably think of a better way to do it next time than using this logic. I'll tell you this logic is here. Now, random numbers. We saw the turtle generate a random number. Random numbers should be unpredictable. And you guys are used to using them a lot in games. All sorts of games will generate a random number for a starting point or what's going to happen next. We can use random numbers to simulate situations or processes. We could use it to pick people, all sorts of different things. So most programming languages are going to have a random function. That's what we saw looking at that turtle thing. So the random function is usually going to generate a random number between 0.0 to 1.0. So it's going to be a decimal number, 0.95, 0.67. In Python, Python's automatically taking care of this for us and multiplying it by 100 so that we get an actual decimal number, because we saw we got 0 or 1. A lot of programming languages won't take care of that for us. And we'll know that we're going to get some sort of decimal value like 0.5, and then we'll need to multiply that by 10 or by 100 or whatever we want to do depending on our logic to get an actual integer number if we want an integer for our random number.
That was how I actually figured out that space. He was doing a random function on a letter or something like that, and so he kept on getting the space as an answer.
Oh, yeah, because it was something in that range. And Python is just so flexible, it's trying to do that.
Well, to combat that, we had to use lowercase letters.
I see. So he was getting a random letter. Fancy. So to change the spread of the range, add the integer. You saw that, the input where we had 0, 1. We could have 0, 7 if we wanted our random numbers to be within that range of 0 to 6. We can also use the int and the floor function in different programming languages to do different things. An int function is just going to chop off the integer part of a number. The floor function is pretty much going to do the same thing. We'll get a list of all of those next week or the week after. But this is an important slide. It's really ugly. It's early in the morning. So take a look at it because there's a lot of test questions generated from this information. So if my random number that I got generated was 0.3792, then if I use this code random times 10, I end up with this number, right, 3.7920. If the random number I generated was 0.0578, then random times 10 would result in still a decimal number. So multiplying random by 10 generates random numbers between 0 and 10, but not including 10. They take this for the test and they ask you all sorts of questions, like multiplying random by 5. What's the range you're going to get for that? So it would be 0 through 4. So just always remember that it's 1 less than that final value that you're multiplying by. We can do a lot with random numbers. They have a lot of great examples. Here's another coin toss example for you for a random number. So we can do this one in Python. They also have a really big dice algorithm there for you. Now, pseudo-random is what happens if I don't have a good seed value for my random number. Now, again, with Python, it's hard for us to make this happen because Python takes care of this for us. So when we say we want to call the random function, Python automatically takes care of the seed value for us. And it's like, oh, a seed value should be extremely unique. So I'm going to use like the current time out to the millisecond is the seed number. That shouldn't be the same seed number he's using or she's using or anybody, because we're all going to get that millisecond being just a little bit different. Now, if I don't start out with a good seed number, if I have a programming language where I can control that seed value and I put in 7, then every random number I generate is going to have the same value. Now, that's important because I might want to use that to test my program. Maybe I want my random number to always come out with the same number so that I know what my test pattern is going to be like. Maybe I want that to happen. So I can control that by using a known seed value. When that happens, when I keep getting the same number over and over from a random number generator, that's called a pseudo-random. It looks random, but it's not. It's giving us the same value over and over and over. So it would be great if we could get like the lottery office to do that accidentally. I think that's why they have that thing about not having any duplicate numbers. No duplicate numbers, right? So the seed has to be something different or else we'll get these pseudo-random numbers. So again, we can use that for testing. So we might, that's an interesting concept. Now, when you guys are looking at loops and nested loops, we've seen already how using that visualizer site can be helpful in stepping through our code. And now we have PyCharm where that debugger can help us step through our code too. Both of those things can help us figure out what's going on. But neither one is going to take the place of a good old desk check. And a good old desk check is where you print that thing out, or you get a piece of paper and look at it on your screen, and you use a piece of paper and a pencil to write down every variable name and what's getting changed by every line of code so that you can walk through all of those lines of code so that you know what's going to happen. Now, we like to do desk checks because there's nothing like just sitting down and looking at it and getting an idea of what's going on. I might do a desk check of someone else's code and tell them that it's too complicated. No, I mean, that's the kind of thing we're looking for when we desk check code. If it's too complicated, maybe we can all get together and work out some logic that's not quite so hard to follow. Or maybe it's too long and stringy. Why do you have 17 if statements? Why don't we just use one? Or this is really, really awesome code. We're going to use it throughout the company forever and ever. That might be the thing that we say too. So this example shows an inner loop and an outer loop. It's very similar to the one that we did that was a nested loop. So I do want you to review those and work on them some more at home. Even the ones that we did in class, you know, we do them quickly. Bring them back up. Walk through them. Tell yourself what each line of code does. Tell your duck what each line of code does, whatever you need to do, because that's what we need to do at this point. Because we have to step through things quickly or you'll fall asleep. So we do move fast sometimes. Now, whenever we're nesting, we can have all sorts of things within other things. We could have a for loop within a while loop. We could have a while loop within a for loop. So none of those things are going to prevent anything else from being within them. Here's one that draws a square. So a lot of these examples that are in the chapter are designed to help you with that lab that we're going to work on next time. So we'll refer to them a little bit. All right, I've beat you down, beat you up, made you wake up, or dropped you completely into slumber, one or the other. Loops and loops and loops. So next time we'll just look quickly at a couple more examples. Email me if you're having trouble with the assignments that are due tonight so that I can help you with them. So I don't want you to be frustrated with them. We can get a Zoom session going between the two of us and probably fix something very quickly. So just let me know if you need that help, and I can try to do that for you. Because we do have a few things to do tonight.
Want to help me with my English homework while you're at it?
No, probably not.
Okay.
You probably don't want my help. Those English teachers say that I do like, what is it? I'm too technical. No, I'm too technical. I do technical writing, not good writing. Just technical writing. Thank you, ma'am.
I want to change my frequency.
What?
I know she thinks about it though.
Gonna put you in Japanese.
She's really upset with me missing so many days. But I can't help that.
What can you do about it?
Yeah.
I apologize for the
Okay.
Yeah, it's family stuff.
Oh no. So you've been getting crazy at your house. Have you been sick, or is it a family stuff that's been harassing you?
Something bad happened over the spring break.
Well, you just yell if there's anything I can do.
Special
I hate these things. You said you're getting student teach. Is that what you're doing?
I'm a student actually.